Hey everyone, welcome back. Today we're diving into operations with polynomials, how to add, subtract, and multiply them. These are core skills that'll help you later with factoring and solving equations. So let's get started. Okay, now the main idea when you're adding or subtracting polynomials is that you have to combine like terms. But let's start by looking at what like terms means. So when we are asked to combine like terms, what does it mean? What are we doing? Now, like terms are pieces that have the same variable and exponent. So remember, variable is actually your alphabet, right? So if I have 3x and I have 9b, I cannot combine these two because my variables are different. I have x and I have b. They're not the same variable. Okay? Now, if I had 3x squared and I have 4x, I cannot combine these because, yes, I do have the same variable. They're both x's, but my exponent is not the same. Over here, I have my exponent of 2. Over here, remember, there's an imaginary 1. So these cannot be combined. Now, if you had 3x squared and you had somewhere floating around 9x squared, that could be combined. Remember, your variable is the same. Your exponent is the same. So let's see. What's 9 plus 3? That's 12. So my answer would be 12x squared, okay? So you're adding the coefficients when you're combining your like terms, but you are not doing anything to your variables and exponents, okay? So when you're combining like terms, you add coefficients, but you keep your variables and exponents common, okay? So remember that. Now, I have some examples here for you just because it's very important for us to practice combining like terms before we actually move on to looking at how to add and subtract polynomials, okay, and multiply polynomials. So I want you to pause the video at this point and find like terms. So find pairs, or even like if there are more than 3 like terms, find them and combine them. Okay, let's look at the first one. So we have 3x squared. Let's see if we can combine it with something else. I can't combine it with 4x because, yes, I do have the same variable, but I don't have the same exponent. I cannot combine 3x squared with 5. I cannot combine it with 4a because that's a totally different variable. I cannot combine 3x squared and 2x because, yes, the variable is the same, but my exponent is not. I cannot combine 3x squared with 2a squared because, yes, the exponent is the same, but they're different variables. I cannot combine 3x squared with 1x. So this does not have a like term in this box. Let's look at the next one. 4x cannot be combined with 5. 4x cannot be combined with 3a because x and a are different variables. 4x can be combined with 2x because my variables are both x's. This 4x has an exponent of 1, and this x has an exponent of 1. So I am going to combine them. So we have 4x plus 2x. Remember, you can add your coefficients. So let's add my coefficients. 4 plus 2, that's 6x, okay? You do not do anything to your variables and exponents. They stay common. You just add your coefficients. So 4x has been combined with 2x. Now, can I add Oh, there's one more. I can also add this 1x because it also has the same variable and same exponent. So that gives me 7x. Okay, sorry. So then this is done, this is done, this is done. Let's move on. I'm going to erase this actually, just so there's a little bit more space. Let's move on to 5. Remember, the term we use for a number that is not attached to any letters or variables is a constant, okay? So now we're looking for another constant, and I do not see another constant, so that's going to be a loner. The next one we see is 4a. So the only one I have left is 4a and 2a squared. They are not like terms because, yes, they do have common variables, but not common exponents, okay? Now we have more information about what like terms are and what they're not. So we are going to be looking at an example of adding polynomials. So adding polynomials can look like this. They can also be something as simple as 2x plus 5x squared plus 3, okay? So this is my first one, this is my second one. It could be as simple as this, okay? Or it could be something a little bit that's more complex, which would be what you see over here. So I have my first polynomial, 3x squared plus 5 minus 1. That is being added to 2x squared minus 4 plus 6. Now, there are two ways to do this. The first one is group like terms. And you always start with the first term and you find terms just like we did up here. Or you can use the stacking method, which is when we align our numbers up, make sure everything's lined up, and then just add right down. We are going to do both, and you can use whichever method you find easier. So let's do the first method, which is group like terms starting at the first term of your first polynomial. So my first polynomial is this, the first term is this. Let's see, so I have 3x squared. Let's see if I have another x squared in my first polynomial. I do not. Let's see if I have x squared in my second polynomial. I do have x squared right here. So that means I have two like terms. So I'm going to do 3x squared plus 2x squared. Okay. I am going to use brackets. Now this is done. This is done. Now moving on to the second term of my first polynomial, I have 5x. So I am looking for another x. I do not see another x in my first polynomial. Let's move on to my second polynomial. Oh, I do see one x right here. So that means I am going to be adding it together 5x plus negative 4x, okay? Now do not let this trick you. Over here, we have a minus sign, and we cannot just take 4x and leave this minus sign here. We have to take it with us. So this minus sign is actually attached to a negative 4, which is why there is a minus sign over here. So that's done, and that's done. Okay, let's do another plus sign, because remember, this is all adding. I know I have to put plus signs because this is a plus sign. Okay, the next term in my first polynomial is negative 1. Okay, so I am looking for another constant, and that is right here. So now I'm doing negative 1 plus 6, okay? So now I'm just going to simplify. 3x squared plus 2x squared. Remember, when you're combining like terms, your variables and your exponents don't change. They stay common, so we're just adding our coefficients, 3 and 2 together. That gives us 5x squared. The next one is going to be 5x minus 4x, that's 1x. And then -1 plus 6, that's 5. Okay, I'm going to write this nicely. So my answer is 5x squared plus 1x, or just x, because that 1 does not really make a difference. And that's your answer. Now, if you were like, I do not understand that method, that totally confused me, you can use the stacking method. Okay, because that is more, it has a more visual aspect to it for some people. So we can always use the stacking method if that's something that makes more sense to you. Oops. Sorry, just trying to cover this up at the bottom so it's not in our way. Okay, so the stacking method, two things. Thing number one, you have to make sure we are in a decreasing order. So your highest power to your lowest power, okay? So let's figure out whether, or let's see if our first polynomial is in that highest to lowest power. I have my highest power, then I have power of 1, then a power of 0, that's good. Second polynomial, I have my highest power, and then power of 1, and then power of 0. So that's good, okay? Which means I'm good. Thing number two, you want to arrange or stack them, okay? Make sure they are aligned. So I'm going to show you what I mean. So I want to put my first polynomial. Underneath that, I'm going to put my second polynomial. Let me use a different color maybe. Now the point of putting them like this is to ensure that my variables and my exponents match. Okay, so my like terms are aligned. So you will see that x squareds match, x's match, and x to the power of 0 or constants match. You want it like this. And then you figure out whether you're adding or subtracting. We are adding. So I am going to put a plus sign over here, which will help me remember. Now you are going to literally just add numbers at this point. So we're adding -1 and 6 together. That's 5. If you don't know how I did that, if I have 1 negative and I have 6 positives, this is one pair, it gets crossed out. That leaves me with 5 negatives, or 5 positives, sorry. Now, the next one, that's a positive, so I'm going to put a plus 5 because it's not a negative number. We are doing 5 plus -4, okay? 5 plus -4. That is 1x. Next, we are doing 3 plus 2. That's 5x squared. Okay, remember this is a positive one, so we're going to have a plus sign. So our answer is 5x squared plus x plus 5. Okay, do you see how both of these answers match? So it does not matter which method you use as long as it's giving you the right answer and it's making sense to you, okay? Now, oopsies, did not mean to do that. Now we are going to move on to subtraction, and it has the same idea. It's exactly the same thing as adding. So the first example we are going to be looking at, sorry, it got erased. I'm going to quickly put it down for us. So the question I initially had was 4x squared minus 2x plus 7 minus x squared plus 3x minus 1. So subtraction is very much similar to addition, but we just have to be careful about this minus sign because we need to distribute it, okay? So let's actually distribute this. So what this means is there's a -1 here, and it applies to all of these. So you can either multiply your x squared by -1. You can multiply your 3x by -1 and -1 by -1. Or you make this minus sign into a plus sign and flip the signs of all of your terms over here, okay? I'm going to show you what I mean. So I can either do 4x squared minus 2x plus 7 minus x squared minus 3x plus 1. So do you see how I put a minus there? I put a minus here and I changed this to a plus sign. And then I just brought this inside, okay? And then I can get rid of these brackets that are around my, first polynomial here, okay? And now I can start with just combining my like terms, where I would go, well, I'm looking at the first term I have, which is an x squared. I am looking for another x squared, not here, not here. Oh, I do see it. And then I would just combine this x squared with this x squared. So then I have 4x squared minus x squared. Remember, there's an imaginary 1. And then you're just doing 4 minus 1, which gives us 3x squared. So that's done. And then you're going to put a plus sign and look at the next one, which is going to be -2x. So you're looking for another x. See one right here. So I'm going to do -2x minus 3x, which is going to give us minus 5x. And then the last one is a constant with a 7, and that can be added to a 1. So plus 7 plus 1, which is going to be an 8, okay? So then we have 3x squared minus 5x plus 8. The other method you could have done this, I'm just going to rewrite the question here. Is you could have changed this into an addition question. So you could have done 4x to the power of 2 minus 2x plus 7 plus, and then you change the signs of everything that's within your second bracket. So -x squared minus 3x plus 1. Okay, then we can do the stacking method. Make sure everything is aligned. Seven plus 1 is 8. That's a positive 8. -2 plus -3 is going to be -5x. 4 plus -1, that's 3x squared. And we get the same answer. So you can either just literally multiply every single term by a -1 and get one giant polynomial, or you change the subtraction sign into an addition sign and just change every single sign that is within your second polynomial. Now we're going to be looking at multiplying polynomials. When we're multiplying polynomials, we actually only multiply the coefficients. But instead of leaving our exponents the same, like when we were adding, we are going to be adding our exponents, okay? So in this case, we're actually multiplying our coefficients, but we're also doing something to our exponents. In adding or subtracting, your exponents stay common. My favorite method for this is the FOIL method because it's the easiest one according to me, and it's very easy for me to remember. So multiplication often with polynomials looks like this. You will have two polynomials in brackets by each other, and that just means they are being multiplied. So when you see something like this is your first polynomial, this is your second polynomial, and they are being multiplied, okay? So FOIL stands for first, outside, inside, and last. So that just means you want to start by multiplying the firsts of your two polynomials. In this case, it'll be x and x. So that's just 1x times by 1x, which gives me 1 times 1 is 1. And then you're multiplying coefficients, and remember you're adding your exponents. So I have an exponent of 1 here and 1 here. So that's x to the power of 2, okay? Outside, that's the one that's the last one, or on the outside. Sorry. So we have first, and then we have outside, which would be x and 5. So the two outer ends. So that's going to be x times by 5, which is just going to be, there's a 1 here. 1 times 5, and this has x to the power of 0. 1 times 5 is 5, x times x to the power of 0, or literally just 0. That's just going to be x, okay? Inside, that's these ones over here. 3 times 1x. So 3 times 1 is 3, and then we just have our x. And then last is going to be 3 and 5. So 3 times 5 is going to be 15. And now you just combine them. So our final polynomial is going to be 1x squared plus 5x plus 3x plus 15. And now you look for any like terms. I do see 2 over here that can be combined. So I'm just going to rewrite this as 8x plus 15, and that's my answer. So let's try one more. Now, what do you do when you have 3 polynomials or more than 3 polynomials? Well, if you have polynomials that have 2 terms, and you have 2 polynomials each with 2 terms, you can actually use the FOIL method to simplify those and then just multiply it with your third one. So let's start by doing 4 plus x multiplied by x plus 2x, and then I'll figure out the 3x. So I'm going to start these ones first. So again, first is going to be 4 and x. So 4 times x is going to give me 4x. Outside is going to be 4 times 2x. That's 8x. Inside is going to be x and x. That's x squared. And then last is going to be x times 2x. Just going to be 2x squared. And now I want to kind of write it as a sentence. I have 4x plus 8x plus x squared plus 2x squared. And I have some like terms, so I'm going to combine them. Okay, that's my final polynomial, and now I can multiply with this 3x. So how I want to multiply? Well, I'm going to take this 3x times by 12 and then 3x times by 3. So let's do 3 times 12. That gives us 36 x squared plus 9x to the power of 3. And that is our answer, okay? You can write this with the highest power first. And that would be your answer, okay? If you have any questions, you can comment them down in the comment section below. And this is just going to be the end of this video. We are going to wrap it up. In the next video, we are going to be focusing on factoring polynomials. Step by step, you'll learn how to take a complicated expression, break it down like a pro. If you liked the video and found it helpful, please like, subscribe, and comment. If you want some practice questions or walkthroughs on your homework, let me know. You have got this, and it's going to be easy once you do more practice. I'll see you next time.